Hi there, I'm Samar, a DevOps engineer and honestly a big fan of clean systems, good pipelines, and tools that actually make life easier. So welcome to Go DevOps, a channel where we take DevOps topics and break them down into simple, practical lessons you can really use. So this new series is all about containerization, from the basics to how it works under the hood and why it becomes such a game changer for modern software teams. So if you've ever felt confused by terms like Docker, images, runtimes, layers, or others, don't worry, we'll go step by step with examples and explanation. So not just buzzwords. And we're starting at the foundation. So with the first episode that is called What is a Container? So it's the perfect starting point if you want to understand what containers are and why they matter. So whether you're a student, a junior dev, or already working in tech, this series is for you. So hit play, subscribe, and let's build better software together. So let's start with the first episode. So let me take you back to one of those moments every student knows too well. You're working on a group project. You've spent hours coding, setting up your Python environment, installing dependencies, debugging line by line, and finally it works on your laptop at least. And you zip the project, send it to your teammate with confidence, and a few hours later they reply, it doesn't run. So you check their error, you find a missing module, version mismatch, a weird OS issue, so you reply, but it works on my machine. So we've all been there. We do everything right, but the app breaks the moment it leaves our laptop, and we spend more time fixing than actually building solutions and coding. So now think about this. If we're struggling to share a simple app with a friend in the same class, what happens when hundreds of developers are working on a massive software system across different cities, different time zones, and even different continents? So how do you make sure the app runs the same for everyone every time? So here is the problem. Traditional software delivery relies on assumptions that the environment on your machine is the same as someone else, but in reality it never is. So your laptop, for example, might be running on a Mac OS with a version of Python 3.11, and your teammate is Windows OS with Python 3.8. So this two big differences already can break the whole setup, but even subtle differences like case sensitivity in file paths or Linux only tools can break the whole setup, and this is what we called environment drift. So it's what happened when the app and its dependencies behave differently in each setup, because every setup is slightly different. So now scale that to a team of 20 developers or a global company deploying across test, staging, and production servers with different operating systems, libraries, network configuration, and security rules. It's a nightmare. So this is why traditional software deployments are fragile, because the app and the environment are separated and anything in between can go wrong. So when we say it works on my machine excuse, the real question is, how do we make it work on every single machine? And the answer is containers. So let me show you a simple metaphor. Imagine you order a lunch, rice, soup, and salad, but instead of putting them in separate containers, the restaurant dumps everything into one plastic bag. So by the time it arrives, the soup leaked the rice onto the rice, and the salad is soggy. It's a mess. So now think of the same meal, but delivered in a bento box. So everything has its own clean, separated section. The rice stays warm, the soup stays sealed, and the salad stays fresh. So that's what containers do for software. So instead of loosely sharing code and hoping it works, we package the app and everything it needs, so dependencies, config, and settings, into one clean self-contained unit. So whether your app run on your laptop, a teammate computer, or a cloud on another continent, it behaves exactly the same. No leaks, no surprises. So just like a bento box keeps food safe and consistent, containers do the same for your app. So now let's take the metaphor one step further from lunch to global trade. In the 1950s, shipping was a chaotic mess. Every port had its own loading rules. Goods were packed in random crates, sacks, or barrels. It was slow, unreliable, and full of human error. And then came one innovation that changed the world. It's the standardized shipping container. Same size, same structure, loaded once, and it can move across ships, trains, and tracks without ever unpacking. So it didn't matter what was inside, whether bananas, computers, or even cars, the system didn't care. The container standardized the process and removed the chaos, and that's exactly what software containers do today. So they standardized the way we package and ship applications, so developers, testers, and ops teams can collaborate without breaking things. One format, one tool set, one smooth pipeline. And just like physical container enabled global trade, software containers are enabling fast global software delivery. So container didn't make shipping faster by making tracks faster. They made instead the handoff smoother, and it's the same for software. So what is a container really? Let me tell you a simple story. So imagine you're packing your favorite homemade dish, let's say pasta, but it's not just the food you want to send. You want the person to enjoy it exactly the way you prepared. So with your special sauce, the right fork, maybe even a little napkin, and a dessert. So what do? You put everything into one lunchbox, you seal it. Now it doesn't matter whether your friend opens it on a train, a park, or on the other side of the world, they get the same experience you intended. So that's exactly what containers does for your software. The code in this case is the food, the sauce that's your dependencies, the fork that's your configuration files, and the napkin or the dessert, maybe the system settings, and all of it goes into one self-contained isolated box, which is the container. So whether it runs on your laptop, on your teammate machine, or a cloud server on another continent, it just works. So no missing libraries, no conflicting versions, no setup headaches. It's not magic, it's just smart packaging. So now that it's packed right, you never have to say it works on my machine again, excuse. So let's be honest, building apps is fun, but shipping them, that's often where things go wrong. So you write code, it runs on your machine, you push to staging, something breaks, you fix it, test it again, you push it to production, and it crashes again. So logs are messy, configs are inconsistent, and the team is stressed, clients are waiting, and of course, deadline don't care. So that's the old way, with manual setup, environment drift, fragile pipelines. Now imagine this instead. You build your app once, package it with everything it needs, and you can run it anywhere from your laptop to the cloud. It behaves exactly the same every time. And that's what container give us. They remove the guesswork, they eliminate it works on my machine excuse, they make environment repeatable, dependable, and scalable. And that's why startup use containers to ship in days and not months, and why companies like Netflix use them to scale globally, and why NASA use them in mission critical systems. Because containers don't just fix codes, they fix delivery, and they bring speed, confidence, and control to everything we build. So containers gave developers back their time, and of course gave teams their sanity. So let's take a look at how they actually work technically. So a container isn't just a zipped folder, it's a self-contained unit that includes your app, all its dependencies, configuration files, and even system tools. So everything it needs to run. But containers aren't built from scratch. They're created from something called an image. So it's a blueprint that defines what's inside the container. So think of it like a recipe. And once it's built, we can use it to create a running container. So like cooking a dish from a recipe. So now to run that container, you need something called a container runtime, like Docker. And the runtime is responsible for starting, stopping, and isolating the container on your machine. And here's the key part. Containers don't run in their own virtual machine. They share the host system kernel, but in an isolated environment. So that's how they are lightweight and fast. And that isolation is achieved using Linux features called namespace and C groups, and they ensure that each container thinks it's running on its own system, even though it shares the OS with others. And where do we get container images from? That's where registries come in. So services like Docker Hub store and distribute images so developers can pull and run them anywhere. So to summarize them, here's how the pieces fit together. So we build a container image, we store that image in a registry, we run the image using a runtime like Docker. The runtime isolates the container using the host kernel. The app runs consistently anywhere. So in one sentence, containers run your app the same way everywhere by isolating it in a lightweight, consistent environment created from a reusable image powered by a container runtime. So why this actually matters to developers, to teams, and organization. So here's the 5 reasons. First of all, we have consistency. So applications behave identically across all kinds of environments, development, testing, or production. Speed, so developers can ship features faster and automate deployments. Portability, so containers can run on any infrastructure, from laptops to public cloud. Collaboration, so teams align around standardized environments, reducing friction and miscommunication. And finally, scalability, so application can be replicated and scaled quickly to handle variable workflows. So what should you take away from this video is that containerization is not just a passing trend. It's a foundational shift in how we develop, deploy, and manage software. It's a practical solution to a long-standing problem in modern software delivery. But more than that, it's a mindset, one rooted in clarity, precision, and the drive to build systems that last. So we need to understand containerization, not just to code, but to deliver real solution at scale with confidence. So thank you for watching this video. I hope containers are starting to make more sense now. So if this helped, feel free to like, share it with a teammate, and hit subscribe so you don't miss what's next. Coming up for the next episode is why containers are lightweight, especially compared to virtual machines. And if you've got a container topic you're curious about or questions, let me know in the comments. I read every single one of them, and see you in the next episode. Thank you.